Hello everyone. It's been a crazy couple weeks. I apologize for not making any videos. I'm actually making this in the morning because the schedule has been so crazy lately. But I did want to go ahead and get this week's video in so that you guys can be aware of what we're going through and you can be working on it with the students at home. We've started this week going over 2 by 2 digit multiplication. So when we first started doing multiplication, we were doing it 1 by 2 digit multiplication, and an example of that would be like 5 times 73. And we went through all of the steps in our previous videos of building this with base 10 blocks. We made 5 groups of 73, and then we totaled all that together. Then we made that as an array. Then we moved into an area model. And the basic design of the area model for a 1 by 2 digit multiplication problem is a rectangle, and we write 5 over here because this represents our number of groups. When it was an array, this was our number of rows, but still this is our number of groups total. The numbers that are going to go up here, the length of this side, is going to be how much is in each group. So we have a total of 73 in each group, and we have 5 groups of that. But none of us like to count by 73, and none of us want to count by 5 73 times. So what we do is we make it easier on ourselves by breaking it into 70 plus 3. And now we can put a partition in here so that we actually have 2 areas. So we have a 5 by 70 rectangle here and a 5 by 3 rectangle here. Well, we can write 5 times 70 in here. We can think of this as 5 times 7 is 35, but it's actually 35 tens. And so to represent that, we need a 0. So we have 350 rather than 35. I don't know if I'm zoomed in enough for you guys to see this. Let me zoom in real quick. Maybe that'll help. And then over here we have 5 groups of 3. So when we're writing this, we can think of the multiplication symbol as representing the words groups of. So we can read it 5 groups of 3. So that's just 3, 6, 9, 12, 15. But 5 times 3 gives us 15. Then we can add these together. 350 plus 15 gives us a total of 365. So then the answer to 5 times 73 would be 365. That's what we did for 1 by 2 digit multiplication. We use a very, very similar model, still an area model, still a rectangle, for 1 by 3 digit multiplication. Let's say we're doing 6 times 245. Still going to put our number of groups on the side. We have 6 groups of 245. But we want to break 245 into 200 plus 40 plus 5. And we put a partition at each of our addition symbols. 6 times 200 would be here. 6 times 2 is 12, but these are hundreds, so we have 1200, which we read as 1200. 6 times 4 goes in here, or 6 times 40. 6 times 4 is 24, and this is tens, so we have 24 tens written as 240. Here we have 6 times 5, and that equals 30. And once again, we would add these together. 1200 plus 240, 1440 plus 30, 1470. And at this point, I really recommend that the students start coming over and adding this together using the standard algorithm, not trying to do it all in their head. Some of the students can, but then what happens is we start getting into some regrouping, especially with the 1 by 4 digit that's coming next, and they make some careless mistakes. So encourage them to come over and check their work. 1470 is correct. So 6 times 245 is 1470. I apologize if it's blurry. Then we moved on to 1 by 4. So let's say we have 8 times 2,487. Still make an area model, just a little bit larger. And we put our number of groups over here. We have 8 groups of 2,487. But we break it into its place values. 2,000 plus 400 plus 80 plus 7. Put a partition at each section. Technically, we want this space to be the largest, slightly less large, smallest, to represent the values of each of these, but I'm trying to do this in a hurry, so you get the idea. We would continue the same pattern. We have 8 times 2,000, 8 groups of 2,000 in this box. We think of 8 times 2 is 16, but this is in the thousands place, so we have 16 thousands. 8 times 400, 8 times 4 is 32, so we have 32 hundreds, or 3,200. 8 times 80, 8 times 8 is 64, but we have tens, so 640, and then 8 times 7. And the ultimate goal of all this is to lead them to, in a couple years, to the standard algorithm for multiplication. We didn't realize it when we were doing it, but when we were growing up learning this in school, you know, we learned to set this up like this, and then you would multiply each digit. But really, what's happening? We're doing all of this just in a box. 8 times 7 is 56. 8 times 8, but this is actually 80. We would get 640. 8 times 4 is 32, but it's actually in the hundreds place, so 3,200. 8 times 2 is 16, but with 16,000. And when we add all that together, it's going to give us our total. But instead of us doing it all out where we can see each individual number or value, we use these. So this 5 here, what often happens is kids want to see this 5 as just a 5, not a 50. So they would get 8 times 8, 64, and they would add 5, and they would put a 9, but they don't realize that 9 is actually 90. And you would get 96. Okay, hold on. Let me just go through this real quick. So 8 times 8 is 64. You add your 5, you get 69. 8 times 4, 32, plus 6, you put your 8 down here, your 3, 16, 19, so 19,896. But each of these comes from adding these together. 16,000 plus 3,000, we get that 19,000. The 200 plus 640, that gives us 840. But then we have 56 added to that, so 896. So this is ultimately leading them to this, but they need to understand the values of each of these for this to really make sense, because you would not believe the amount of ways that I've seen students confuse this. So just trust the process for me, please, and keep letting the students work this way. Okay, that was a review. Now to this week. This week, we got 2x2 digit multiplication problems. So, being Christmas time, we have some Christmas-themed questions, if it will quit being blurry. All right, number 1 says, Santa is packing gift bags. Each gift bag contains 24 small toys. He prepares 36 bags. So we ultimately have 24 times 36. We're going to do this the exact same way, still with an area model. Only difference is, instead of, like when we had 4 times 36, and we had 4 groups over here and 36 up here, and we broke it into 30 plus 6 with the expanded form, we're going to expand both of these numbers. So 24 can be written as 20 plus 4. And so we have 24 groups of 36. But we can split both 24 into 20 plus 4 and 36 into 30 plus 6. Now we can still draw our partitions at the plus signs, at the addition symbols. But now we've got 4 areas. So this is a 20 by 30 box. This is a 20 by 6 because rectangles, the opposite sides, are the same length. So if we wanted to label these, we could label the opposite sides. This is 6, so that is 6. This is 4, so that is 4. This is 30, so that's 30, and so on. But we can think about this as a 20 by 30 area. So then we think of this as 2 times 3 is 6, but each of these is a multiple of 10. So we actually have 10 times 10 going on over here. So we're going to multiply this by 10 times 10, which is 100. We have 600. Over here we have 20 groups of 6. 2 times 6 is 12, but it's hundreds, so 120. Then we have 4 groups of 30, so 4 times 30. 4 times 3 is 12. This is tens, so 120 again. And then we have 4 groups of 4 here, which is 16. And then we add all of these, what we call partial products. I can't believe I haven't mentioned that this whole video, but these, the 20 times 30, 20 times 6, 4 times 30, 4 times 4, these are all partial products. And we can actually, we don't even need the area model. If we can recognize that 24 times 36 can be split into 20 plus 4 times 30 plus 6, we could actually think about multiplying each of these. So 20 times 30, we see that over here. 20 times 6, we see that here. 4 times 30, we see that here. 4 times 6, we see that, whoop. I just realized I did the wrong thing here. See, double check. 4 times 6 should be here. 4 times 6, 24. All right, make sure you always check your work, because even us teachers, we make mistakes, especially when we're trying to rush. But once you have all these, you would write 20 times 30 if you didn't want to use the area model, and you add it to 20 times 6. Add that, and I'm going to run out of room here, but 4 times 30 and 4 times 6. And then we would add together all these totals. So this is 600, this is 120, 120. I'm making a mess of this, and 24. We add all that together, and once again, we could come to the side and check our work by using the standard algorithm for addition, where we stack our stack our numbers according to place value. Nothing plus 4 is 4. 2 tens plus 2 tens plus 2 tens is 6 tens, or 60. 600 plus 100 plus 100 is 800. So we have a total of 864. So 24 times 36 would be 864. All right, there's a crash course in 2x2 digit multiplication. If you have any questions, as usual, just reach out to me through Class Dojo or email or school status or whatever you have access to. Y'all have a great weekend.